Welcome dear learners. We are continuing Unit 3 Introduction to Nanomaterials. In this module, we are focusing on synthesis of nanomaterials, the top-down approach. The contents of this module are the synthesis of nanomaterials, two approaches, introduction to top-down approach, popular top-down methods, selected top-down methods with their description. First of all, synthesis of nanomaterials. Two different approaches are there for the synthesis of nanomaterials. We are going to detailed discussion of the two different approaches of synthesis of nanomaterials. This picture clearly depicts two different approaches of synthesis of nanomaterials. The two different approaches are top-down approach and bottom-up approach. Before entering into the more details of these two approaches, I am just mentioning what is meant by top-down and bottom-up approaches. In the top-down approach, as the name indicates, we are beginning from a bulk material or from the top. A bulk material is scaled down, broken down into small nanoparticles. That is, in the top-down approach, we are beginning from a bulk material and gradually scale down them into small nanoparticles. And the next one is an exactly opposite approach. Here we begin from atoms or molecules which are smaller than nanoparticles, and we assemble that atoms or molecules together to produce the nanomaterial. That is, in bottom-up approach, we are beginning from particles which are smaller than nanomaterial and assemble them together to get to the nanomaterial. Here we start from bulk material which are bigger in size compared to nano, scale down them to nano. That is top-down. Next approach is exact opposite. Here we are beginning from very small particles which are even less than nanoparticle size. We have to assemble them and finally convert it to nanoparticles. So these two are two exactly opposite approaches. We can enter into more detailed description of these two approaches. First of all, top-down approach. Nanomaterials are synthesized by breaking down of bulk solids, bulk materials. Here we are beginning from the bulk material and scaled down, broken down into nano-sized particles. This is the concept behind top-down approach that I mentioned earlier. Now, it is based on the principle of dispersion. A bulk material is totally assembled. It is broken down and separated. So, there is a dispersion. It is based on the principle of dispersion. Now, the starting material for the top-down approach is generally in the solid state. That is, we take a bulk material, a bulk solid, it is broken into small particles. Finally, we are getting the nanoparticles of desired size. This is the top-down approach. Now, this is a pictorial illustration of the top-down approach. The left-hand side represents a bulk material which appears as a rectangle. Here x direction, y direction and z direction, all directions are outside the nano regime. Hence, this can be considered as a bulk material. It is first broken into small fragments which are not still nano, and that fragments are again broken into small sized particles, that is nothing but nanoscale structures. So, these fragments can be considered as an intermediate stage between the small nanoparticles and the bulk material. So, the bulk material broken into small fragments, again broken into desired size of nanoscale objects or nanoscale structures. This entire procedure is known as the top-down synthesis, and this approach of considering or converting the bulk material into nanoscale objects is called the top-down approach. Now, we are entering into the details of the opposite approach. The opposite approach is called bottom-up approach. In the bottom-up approach, nanomaterials are synthesized by assembling atoms or molecules together. This is most important, atoms or molecules together. Now the question arises, what about the size of an atom or a molecule? Definitely it is less than size of a nanoparticle. Atoms and molecules are smaller particles compared to nanoparticles. So, we have to take very small atoms or molecules and assemble them together. We have to assemble them. We have to group them together to produce nano-sized objects. Here we are beginning from particles which are less than nanoparticles, assemble them together to convert it into nanomaterials. So, the starting materials may be atoms or molecules. The starting material may be in the physical state of gas or in liquid state. But in the previously discussed top-down approach, you have to remember the fact that the starting material is in the solid state. The starting material here in bottom-up approach is either in gaseous state or in liquid state. Now, this is the pictorial representation of the bottom-up approach. Here you can see the very small atoms and or molecules, which molecules are assembling atoms, combining atoms to get to molecules. So, molecules are somewhat bigger than atoms, okay, component atoms. So, here I am representing atoms. Atoms are very small. The atoms connected together to get an intermediate stage that is called a cluster. Atoms first join together to get clusters. Clusters again converted to nanostructures. So, from the picture, it is very well clear that the smallest particles are atoms and the biggest one is nanoparticle. In this picture, there is an intermediate also. The intermediate is clusters. So, what are nanoclusters? Nanoclusters are assembly of atoms which are less than nanoparticle size. The size of nanocluster is less than nanoparticle but greater than atom. So, atoms first assembled together to get clusters, clusters converted to nanoparticles. So, this is a gradual assembling procedure. Atoms assembled together to get clusters, clusters assembled together to get to the nanoscale structures. This approach is exactly opposite to the top-down synthesis, and this approach or this kind of synthesis is called bottom-up synthesis or bottom-up approach. Now, this module is very significantly discuss two type of approaches initially and more detailed about the first approach, top-down approach. Before entering into details of the top-down approach, different procedures under top-down approach, we have to consolidate these two synthetic approaches together. And this picture is a very nice illustration of two approaches together. The left hand side is a bulk material, right hand side is the smallest atoms or molecules. If I move from left to right, the middle portion occupied by the nanoparticle. In the bulk material, first powdered to get some powders or fragments, it is again powdered to get to the nanoparticle. So, from bulk to nanoparticle, this portion, this half portion up to this portion represents the top-down approach. And if we begin from the right-hand side comprised of small atoms, atoms assembled first to get clusters, clusters assembled to get to the nanoparticles. So, from atoms to the middle portion, that is at middle there are nanoparticles. So, atoms assembled to get clusters, clusters to nanoparticle. That is exactly opposite approaches of top-down. That approach is called bottom-up. So, From left to the middle, it is top-down approach, and from right to the middle, that is bottom-up approach. The middle portion occupied by nanoparticles. These are the two different approaches together, the consolidation together. Now, it is more clear, very well clear, another illustration. These are atoms or molecules, again two clusters. The middle portion shown here is nothing but nano arrangements or nanoparticles. This is bulk material. It is converted to powder or fragments, again assembled, again broken down to get the nanoparticles. This is another illustration of the two synthetic approaches. So, it is very well clear that in nanotechnology, there are two important procedures, two important approaches for the preparation of nanomaterials. That two approaches are very well clear to you now. They are top-down approach and its opposite approach, that is nothing but the bottom-up approach. And as I mentioned earlier, this module is especially intended to discuss popular top-down methods with their characteristic features, etc. So, I am entering into that title, popular top-down methods. What are various top-down methods? There are so many top-down methods for the synthesis of nanomaterials. We can have a glimpse on some popular top-down methods. The top-down methods includes RF plasma method, radio frequency plasma method, that is RF plasma method. Next one is thermolysis. Thermo means temperature, lysis means fission. You are heating something to get to the nanoparticles. That is actually happened in the thermolysis. We can enter into details in coming slides. And next one is mechanical grinding. It is otherwise called high energy ball milling, similar to powdering of some granaries or some materials. This is mechanical grinding. Okay. Now, the next method is very popular, very important method, that is recently discovered method also. That method is called the laser ablation. Laser ablation is one of the popular, recently established top-down method. Now, another top-down method is nanolithography. These are very recent techniques. Nanolithography comprised of two subdivisions. They are nothing but electron beam lithography, where we are using high energy electron beams to prepare nanoparticles, and photolithography. As the name indicates, photons, light energy is used to prepare the nanoparticles. So, these two jointly come under the category of nanolithography. So, nanolithography is a popular top-down method. Now, another one is sputtering. Sputtering is also a top-down synthesis of the nanomaterial. Now, we are focusing some selected top-down methods, their detailed description. So, we heard about two important synthetic approaches for the synthesis of nanomaterials. They are the top-down approach and the bottom-up approach. And we heard some selected topics under top-down approach. And now, we are going to study each method, not at all methods, selected top-down methods in detail. That is, first of all, we are discussing the RF plasma method. We can enter into the details of RF plasma method. So, before entering into the more details of the RF plasma method, we have to keep some important points in our mind. There are two approaches, top-down and its opposite approaches, that is nothing but bottom-up approach. Popular top-down methods, RF plasma, laser ablation, lithography, etc. You have to just remember that. And with that details in your mind, we are entering into more details of the first method. That method is called RF plasma method. In RF plasma method, we are using radio frequency radiations. Moreover, this RF plasma method is the oldest technique for the preparation of nanomaterials. And this RF plasma method is highly useful, especially for the preparation of metal nanoparticles. Metal nanoparticles can be abbreviated as MNPs, metal nanoparticles, platinum nanoparticle, iron nanoparticle, gold nanoparticle, silver nanoparticle, very popular. Such kind of metal nanoparticles or MNPs can be prepared by this RF plasma method, which is one of the oldest top-down method for the synthesis of the nanomaterials. Now, this RF plasma method involves, this is the procedure behind RF plasma method. This RF plasma method involves the vaporization of the bulk metal. For example, if you wish to prepare silver nanoparticles, you have to begin from a bulk silver metal, bulk piece of silver, and that metal is subjected to vaporization. So, you are getting silver vapors. And that vapors is allowed to cool or to condense, and that condensation happen to a solid surface or on a surface, on a suitable surface or on a suitable substrate. So, here there must be evaporation or vaporization. Vaporization followed by condensation. During condensation, you will get small sized metal nanoparticles or MNPs. Now, metal placed in a container in an evacuated chamber is heated using high voltage radio frequency coils. So, only after heating you will get vapors. That vapors has to be condensed on a suitable surface, and helium gas is then injected into the system to form a high temperature plasma. Yeah. This why the name RF plasma. The RF plasma is, RF stands for radio frequency. You are using radio frequency coils to generate the heat, but plasma is obtained by the ionization of the noble gas helium. So, inside a chamber, you have it to heat by using radio frequency coils. The chamber is already filled with the helium. That leads to the generation of the plasma. So, the complete heating, the complete evaporation of the metal taken inside the chamber is happened with the aid of plasma. Plasma is generated with the help of RF coils, hence the name RF plasma method. Okay. Now, this is the illustration, this is the pictorial representation of the instrumentation used in the radio frequency plasma method. Here you can see some RF coil. Here there is a metal which is shown in black. This is the metal, either maybe silver or platinum or gold, any metal from which you are going to prepare the nanoparticles. And there is an RF coil. That RF coil is surrounded your metal, and this chamber is entirely filled with the helium gas. The RF coil generates some heat energy. Heat energy leads to the generation of the plasma from helium gas. That plasma causes the evaporation of the metal. The metal is subjected to vaporization. Metal vapors are produced, and that metal vapors has to be condensed. And that metal vapors are condensed on the surface of a rod or a metal called collector rod. So, the procedure is like this. Metal, bulk metal converted to vapors first, followed by condensation on a collector rod or on a surface. This is the procedure behind RF plasma method. Now, the metal vapor nucleate on helium gas, this is the procedure during condensation and vaporization. The particles diffuse towards the collector rod. I already mentioned about the collector rod where the vapors deposit as nanoparticles. The reactive nanoparticles are finally passivated by introducing gas like oxygen. This one is most important. You know the fact that the nanoparticles are highly reactive. In certain cases, you are getting the product nanoparticles which are highly reactive. So, to prevent their reactivity, we have to passivate. We have to passivate it. We have to make them inert. For that, we are passing oxygen gas. So, oxygen react with the metal nanoparticle, and the surface of which is converted to metal oxide. Hence, we will get stable nanoparticles. That process is called passivation. Passivation by passing oxygen. This is also we have to perform during the RF plasma method. Now, we are entering into more details of the second procedure. The second procedure, the second top-down approach, that is called the thermolysis. Here two terms are here. Thermo means temperature, lysis means fission. So, you are heating and breaking something. That is the procedure that we are going to discuss. Yes, the details of the thermolysis are, thermolysis is the decomposition of solids. The starting material for the synthesis of the nanomaterial is a solid. In top-down approach, generally the starting material is a solid that I mentioned you earlier whenever we are comparing the top-down and bottom-up approach. Here also, thermolysis is a top-down synthetic procedure. So, the starting material must be in the solid state, and in thermolysis, we are performing the decomposition of the solids at a high temperature. Decomposition of the solids at a high temperature. So, heating and breaking, that is the terms used in thermolysis. It is commonly used for again the MNPs, metal nanoparticles. As in the previous case, as in the previous RF plasma method, the thermolysis is also highly useful for the creation of various kind of metal nanoparticles. The solid should contain metal cations and molecular anions or metal organic compounds. These may be the starting compounds. Yes, metal organic compound can also be the starting, or a salt can also be the starting material. The material is placed in an evacuated quartz tube and heated to decompose. The obtained nanoparticles are finally passive. Passivation is to make them inert, to make the nanoparticle inert. By passing oxygen or any other suitable gas, you can make inert. So, this thermolysis is performed in a quartz tube. Okay, we have to start the starting material and place it inside a quartz tube and subject it to heating. With that much strong heating, the material is decomposed to get to the nanoparticles. In order to prevent the nanoparticles from further reaction, we are making it passive by passing gases like oxygen, etc. And this is the pictorial representation. This is a quartz tube. That quartz tube can be externally heated with the help of the furnace. The sample is present here. The sample material is subjected to strong heating, and as a result of strong heating, it is decomposed. You can control the pressure inside the quartz tube by using a vacuum gauge. You can regulate the pressure also, and finally by passing some other gas through the system, some suitable gas through the system, the obtained nanoparticles can be passivated or make them inert. Now, the third top-down approach, this is also a very popular method. This is similar to this approach adopted here is similar to powdering our common chili or powdering our rice, etc. by using a mill, a flour mill or like that. Okay. Here we are producing small sized nanoparticles with the same procedure what we adopted in flour mills. Okay. So, mechanical grinding or high energy ball milling, it is otherwise called attrition. All these are synonyms: attrition, high energy ball milling or ball milling, or mechanical grinding is simply, as we know, it is a top-down procedure, and we can enter into more details of the mechanical grinding. So, it is a popular method due to simplicity and relative inexpensive nature compared to other top-down approaches. This mechanical grinding is quite inexpensive. We can adopt it for the preparation of several kind of nanomaterials. I again give emphasis to the word, this mechanical grinding is similar to the powdering of our rice or chili or some other materials in a flour mill, Okay. So, the procedure, here we are adopting that flour mill procedure principle to get nanoparticles. We can enter into more details of this mechanical grinding, and used in this mechanical grinding used in the synthesis of varieties of nanomaterial. See, the RF plasma method and the thermolysis exclusively used for the preparation of metal nanoparticles, but this can be adopted for metal oxide and various kind of nanomaterials. So, this mechanical grinding is inexpensive procedure, popular procedure, very easy to get to the nanoparticles. There are several advantages and some disadvantages also that we can consider in coming slides. And milling is achieved by high energy shaker, planetary ball or tumbler mills, and this is the arrangement. These are two high energy balls made up of some steel alloy or some refractory materials. What are refractory materials? You heard it in your plus 2 or school classes that refractory materials are materials which can withstand high temperature, and these balls must be made up of hard refractory materials. Why we are using hard refractory materials? If we are not using a refractory material, the rubbing, the movement of the ball may generate high temperature, and that high temperature may lead to the melting of the material used in the preparation of the ball. So we have to use either stainless steel or steel balls or ball made up of some refractory materials. See, the space in between these two balls, can be controlled, can be arranged. That space ultimately has a connection with the size of the nanoparticles obtained. If you wish to prepare very small nanoparticles, ultra small nanoparticles, you have to place these two balls very close to each other, such that you will getting the particle coming out will be small sized. If the space is high, the size of the particle obtained will be high. So this procedure is the illustration of mechanical grinding, and we have to provide an inert atmosphere also. Inert atmosphere like noble gas etc. is a preferred atmosphere. Now, the energy transferred to the powder from the balls. There are balls which are moving in opposite direction, and these high energy balls, energy transferred from that balls to the particle depends on many parameters. What are that parameters? Rotational speed, the speed in which the balls are moving, number and sizes of the balls. Bigger sized balls can be used, small sized balls can be used, more than 2 balls can also be used. The time of milling, how much time that ball is moving, the milling atmosphere, whether it is an inert atmosphere or air, like that. That atmosphere is also has a role which depends on, or sometimes we are also performing vacuum milling. Okay, so the energy transferred from high energy metal balls, high energy refractory material balls to the nanoparticles, to the particles is governed by these parameters. These parameters are very important as far as the mechanical grinding is concerned. Now, nanoparticles are produced by the shear action during the grinding, Now, some advantages, disadvantages, etc. We can first stick on the advantages of mechanical grinding. It is low installation cost, it is low cost of grinding medium. The medium may be a noble gas or inert medium. Then suitability of both the batch and the continuous operation. You can continuously run this instrument. Yes, huge quantities can be prepared, capable of both the open and closed circuit grinding. You can also perform it in an open arrangement, or this can be performed in a closed arrangement. You can use the vacuum, you can use some other media as the atmosphere to provide the inert atmosphere, etc. It can be used on materials practically any degrees of hardness, that is low hardness, materials with low hardness, materials with high hardness, etc. Varieties of nanomaterials can be prepared by using different kind of solid state starting materials, which may be hard, which may be moderately hard, whose hardness is very low, etc. So these are some important advantages of the mechanical grinding, and with this we are moving on to another top-down approach for the synthesis of nanomaterial. Whenever I am mentioning about the various methods in top-down approach, I already mentioned about the laser ablation. It is nearly a recently discovered technique. It is highly important, and we will get a clear nano-sized particles of uniform size, uniform shape, etc. So, laser ablation is a very important procedure for the synthesis of the nanomaterial, and we can enter into the details of the laser ablation procedure. Laser ablation synthesis involves nanoparticle generation using powerful laser beam. Here we have to use a high energy laser beam, and that laser beam hit on the target material, which cause generation of the nanoparticles from the target material. Here in the laser ablation procedure, material is removed from the surface of a sample by a laser irradiation. We are chipping, we are just removing small nanoparticles from the surface of a bulk material with the help of a laser. We are cutting vegetables with the help of a knife. In a similar way, we are taking a bulk metal or a bulk material and chisel them and converted them into small particles with the help of laser radiations, high energy laser beam. That is the principle behind laser ablation. The irradiated laser beam is absorbed on the sample, leading to rapid increase in the temperature. That increase in temperature may generate the formation of the nanoparticle. And this result the vaporizing target material into laser plume. And this vaporized, this is the procedure. The laser plume or the vapors of the vapors finally subjected to condensation. Condensation leads to the generation of the particles or clusters. Clusters are particles which are less in size compared to nanomaterials, but bigger in size compared to atoms or molecules. So you can even prepare that nano clusters with the help of the laser ablation procedure. The condensed particles can be deposited onto a substrate or collected using with the help of a filtering mechanism. You can separate the particles of desired size by placing a suitable filter with the instrumentation. Now, the irradiated beams is absorbed on the sample surface, thereby rapidly increasing the temperature. This is vaporization of the material. This procedure we have previously explained. And the instrumentation of the laser ablation technique is shown here. The two parts of the instrumentation is shown here. Here we have to use a pulsed laser, and that laser creates the high temperature, and there is a chamber called ablation chamber where the entire process occurs. This is a simple pictorial illustration of the laser ablation procedure. No much details are required as far as your syllabus is concerned. This is for the simple illustration. Here you can see the presence of a laser beam, and that laser beam targets on a material. Some vaporization occurs. Vapors are subjected to condensation. Condensation leads to the formation of nanoparticles or that nano clusters. So this laser ablation is a very important technique used for the preparation of highly precise nanoparticles with uniform morphology, size, etc. Now, so many advantages of this method. It can be considered as a green technique as there is no stabilizing agent or chemicals are used for the synthesis. What are stabilizing agent? This matter has to be considered very seriously. In order to stabilize the nanoparticles without to prevent their precipitation or agglomeration, we have to cover the nanoparticles with some other chemicals, and they are called that stabilizing agents or capping agents. So, in the laser ablation procedure, we are not using such a kind of capping agent or stabilizing agent. So, that reduce the usage of the chemicals, and hence we can consider this laser ablation as a green technique, which is eco-friendly technique. Okay. Now, this laser ablation can be performed using both the pulsed wave and a continuous wave. I mentioned during the instrumentation I used a pulsed wave. Instead of a pulsed wave, I can use a continuous laser. So for that, I have to make some slight modification in the instrumentation, that is regarding the experimental performance, and you can use two kind of lasers, either pulsed wave laser or continuous wave laser for the synthesis of nanoparticles through laser ablation procedure. Low heat transfer is transfer to the surrounding, and this low heat transfer again forced us to say that this laser ablation is a green or eco-friendly procedure. Wide range of nanoparticles, metal oxide, metal nanoparticle, some different kind of solid state nanoparticles can be prepared by this laser ablation method. Another procedure is nanolithography. The word nanolithography comprised of some parts, especially three parts. What are they? Nano, as we know, nano means dwarf, small particles. Litho means stone. Lith means stone. Graphy means writing. So, nanolithography. What is the meaning of that? It represents tiny writing onto stone. Tiny writing onto stone. That is the name behind nanolithography. That is the elaboration of the name nanolithography. Now, the procedure in general, we start with a bulk solid. This is because we are discussing the top-down approach. The starting material must be in the solid state, and nano-sized patterns are developed by removing unwanted parts from the material. There are different types of nanolithography. We need not to consider more details of the nanolithography techniques that you can study in your higher classes whenever dealing with the more synthetic procedures of specified nanomaterials. So we are just mentioning about the aspects, various top-down methods only, basic ideas about the top-down methods only, and based on the tool we used it to chisel or break the object into nano level, there are several types of lithography, and some important lithographic techniques are electron beam lithography, where you are using high energy electron beam, photolithography, you are using photons, and another modification is nano imprint lithography. These are various classifications of the very important technique nano lithography. We don't want to consider more details of each and every lithography techniques that you can study in your higher classes. Now, sputtering. Sputtering is a very important method which is also recently discovered technique for the preparation of the nanomaterials. Here, it is used to produce nanomaterials via bombarding or hitting solid surface with high energy particles, and it may be the high energy particles may be plasma or gas. So, sputtering is bombarding or hitting. So, in order to generate nanoparticles by the sputtering procedure, I am just mentioning about the principles of the sputtering procedure, not much detail is required, and the sputtering is a process used to produce the nanomaterials, and it is obtained by, here the particles are generated by bombarding the solid surface. The starting material is a solid, and that solid surface is bombarded or hitted with the high energy particles. It is an effective method for producing thin films of nanomaterials. You know about the thin films. In the previous session, we heard about the thin films also. Thin films are two-dimensional nanomaterials. Thus, thin films can be prepared by this sputtering technique. And in the sputtering deposition process, energetic gaseous ions bombard the target surface, causing physical ejection of small atom clusters, and that atom clusters aligned together to produce the thin films. The sputtering is generally performed in an evacuated chamber to which the sputtering gas or plasma is introduced. At a high voltage is applied to cathode, and free electrons collide with the gas to produce gas ions. That gas ions leads to the formation of the nanoparticles. This is a pictorial illustration. No much details are required as far as your syllabus is concerned. Positive ions strongly accelerate to the electric field and hit on the cathode target, resulting in the ejection of the atoms. That atoms assembled together to get to the nanoparticles. So, here we are bombarding the starting materials with some high energy particles. Now, after the discussion of various top-down methods, we have to finalize our discussion. Before ending of the discussion on top-down synthetic approach, we have to consider the advantages and disadvantages of the top-down methods, and the advantages of the top-down methods are here. The first one, large scale production is possible. We can prepare huge quantities of nanomaterials, even very large quantities, and deposition over large substrate is possible by this thin film coating, etc. is possible by this method. Generally, chemical purification is not required. That means the obtained particles are more or less pure, and they are highly pure. So, generally chemical purification is not required. For every method, there are disadvantages also. Here are some notable disadvantages of the top-down procedure. The size distribution is broad. It is in the range of 10 to 1000 nanometer. The size different sized nanoparticles are obtained by the top-down approach. Varied particle shape or geometry, that is, the particles obtained not to be spherical, it may be in rod shape, it may be like a planar or a different shaped nanoparticles can be prepared, not all uniform shape. Defects or imperfections may get introduced and compared to bottom-up approach. These top-down approaches are expensive techniques. So these are about the various disadvantages of the top-down approach. Hence, by this module, we have learned about the two different approaches and considered top-down approach and selected top-down methods in more detail. Have a nice learning experience. Thank you.